Self-clinking fasteners with Arbor press. End-to-end tooling process how to convert Arbor press into the fastener insertion tool using basic garage workshop tools and home depot components. Self-clinking fasteners are a great invention. They enabled and simplified a lot of processes in enclosure design, especially using lightweight materials like aluminium and plastic. In my everyday project, I am using nuts for sheet metal, studs and pins for sheet metal, and standoff for sheet metal. This technology is especially important when making prototypes and enclosures from aluminium sheet metal because threads are not strong enough for long-time reliable usage. Let's take a look to the famous manufacturer PEM Industries marketing materials, stating key benefits of self-clinking fasteners. They provide strong threads or attachments in metal as thin as 0.20 mm. May be installed using any parallel acting squeezing force. Provide high push-out and tortage-out resistance. Don't require special hole preparation such as chamfering and debloring. Reverse side of metal sheet remains flush, no swage rim protrusions. No retaping necessary after applications, low installed costs. Can be installed using automatic equipment for high-volume productions. Let's take a closer look how previously mentioned type of fastener insertion process looks like. You need anvil, punch, and force. We do have small mechanical prototype lab with limited space and specialists, so industrial solutions are not an option. For prototypes, we are processing only aluminium with greatly lowering requirements for a fastener insertion force. Standard Arbor press providing force of 1 ton is more than needed. For small fasteners with 3 mm threads, necessary force is about 300 to 500 kilograms. The challenge for limited volume prototyping is lack of small series insertion equipment. Practically you can get only industrial grade machines with a high price tag and heavy weight for stationary installations. Even the smallest insertion machine PEMSET Series 4 is kind of prototyping lab monster. Of course it's good machine, but together with all accessories and shipping you should spend about $1,500 USD. When taking closer look to machine drawing, it's a big U-shape with anvil and punch. Dimensions are given. And simplifying concept, machine consists of anvil and punch of 16 mm round metal part and force applied. For my work I need 3 variations of anvil and only 1 flat version of punch with 30 mm insertion part, no longer than 25 mm, to fix it in Arbor press. In specifications you can see that smallest PEMSET Series 4 machine weight exceeding 250 kilograms. That means one person or even couple of persons can't move it. At least not person like me with weight of 85 kilograms and trained more for endurance than weightlifting. Used equipment prices are a bit lower, but you need to count extra costs for shipping and be ready for surprises. A good Arbor press price is just a couple of hundreds of euros, and even smallest version may suit for prototyping purposes. I took DDP-20 with total weight of 33 kilograms and maximum force of 12 kilonewtons. What is more than 1 ton? This version has a factory drilled 13 by 25 mm hole in a stroke. Perfect for my project. For those who has access to lathe machine, it's very simple project. I do not have necessary skills and going to make parts using basic instruments, drilling and sanding machine. To minimize metal work, I took anchor stud and adapted to my project. Those are broadly available in large home depots and specialized shops for construction materials. A lower part will be used for anvil holder. Upper part for punch. In ideal world I need 2 anchor studs, but let's be realistic about basic skills and I purchased 5 of them, considering some learning path as well. Anvils will be made from the standard 10 mm screws. I'm not good at imperial units, and in this project I'll be talking in metric dimensions. Let us measure anchor stud and estimate metal work needed. There are precise 25 mm lengths to secure punch and Arbor press stroke, with diameter of 12.5 mm. Perfect for my project. Total length of the punch is about 86 millimeters. And working length 56 millimeters. It is almost perfect. I just need to cut them and ensure that surface is flat. From the lower part I will make an anvil holder with total length of 140 millimeters. And the threaded part is about 80 millimeters, what is more than I need. I will have room for some adjustments if needed. The diameter is close to 16 millimeters, what is industrial standard for such equipment. To secure an anvil holder in Arbor press, we are going to use a couple of 16 millimeters nuts and different type of washers. Seems that it may work. All of those components are available in large homemade depot shops. To secure anvil holder I need 25 mm space. I have 40 mm and have extra space for adjustments for anvil holder height in Arbor press. That may be needed for optimum Arbor press handle positioning. Big square washers are standard mechanical components and available in home depot or construction material shops as well. Just checking basic dimensions for them, they're meant to be 50 by 50 mm in size and 4 mm thick. Anvils I'm gonna make from 10 mm screws with hex wrench hole. Screws head is 16 mm round type, just what I need. Here you can see basic tools that I'm gonna use for this project, nothing fancy. Couple of tools where I did careful investments. I bought new factory sharpened high quality cobalt metal drill bits. It is critical for project success. We need to drill long precise 10 mm hole to make an anvil holder. Altogether you need 3 drill bits, 10 mm, 4.2 mm and 3.2 mm, plus 6.5 or 8 mm mill for metal work with flat end. I didn't find 6.5 mm mill and used 8 mm mill. You also need some special drill bits to make a precise start mark in metal. I think correct term is a central drill. You may succeed without it using central punch. In my practice it is better to use it. Result is more predictable. There you can see typical example of lack of experience. I thought that screws will be very hard to cut and purchase a lot of spare metal saw cutters. In fact, for this project you need only one good cutter. Important note: for this project you need good vices with hardened clamps. It is important. Success of the project depends how precise and rigid you will be able to secure material. You need vices with price range of 60 euros or higher and from proven manufacturer. I have German manufacturer vices, the good ones. And you need industrial drill press, not a hobby type. 90-degree adapter for grinding anvils and secure 90-degree settings. I made it from plywood. With 90-degree angle I set the grinding machine to 90 degrees, and now we are ready for the project. Those settings are important. When pressing self-clinking fasteners, anvil and punch surface should be flat. First operation: remove thin metal part from the anchor stud. It is a relatively simple process, but anyway you need a little bit practice. Next, cut anchor stud to necessary length and shape. In our case, for punch, it is right to the end of the thread. One more important element: safety. You must, with emphasis to must, use protection gloves and glasses. During the drilling and sanding process, material can achieve high temperature and it is easy to get injury burning your fingers. Let's see how hard this cut 16 mm metal anchor stud. Actually, it is not so hard and I was pleasantly surprised about the process. It took about 3 minutes to cut it. After cutting, we need to sand it to perfect shape, angle and surface treatment. At some point sanding machine did a great job. Honestly, I was not sure how it will go because sandpaper doesn't apply to disc evenly. With slight push and rotating metal part I was trying to get necessary surface flatness. To keep part at 90-degree angle, I was using plywood parts as a guide. This is a moment when metal part temperature rising rapidly. Outcome is good. Flatness is great. I took control measurement with straight angle meter. Everything seems perfect. The hardest procedure for punch is done. The next we should cut excessive metal lengths to secure punch and arbor press. Tolerance here is unimportant. We need to be below 25 mm length. Little bit of sanding and we are finishing first critical component in our project. Result exceeding expectations. So far so good. It was a good idea to use anchor stud as a base. I don't need surface treatment and other post-processing activities. Let's make anvil holder. In this case I should cut anchor stud upper part. I already gained practice how to work with metal saw and feel far more confident about cutting capabilities and time. Wearing the thick gloves gives extra confidence to apply necessary cutting force. The biggest challenge is how to center workpiece in a drill press. I do not need a perfect tolerance, but drilling straight in the center may give some personal satisfaction. Workpiece may look more professional with perfect center hole. I took long 10 mm screw and carefully aligned parts by moving vise. When parts were aligned, I secured a vise. Then with the center bore we drilled center hole for 10 mm drill bit. There we should be careful. Center bit is kind of fragile tool. It is easy to break if applying extra force or being impatient. The same applies for drilling. Use low RPMs and go with the passes to avoid overheating of drill bit. Cobalt drills can last long, even drilling hard materials, but overheating will damage it easy. A lubricant reducing risks for overheating and needed force. In the video you can see passes, like repeating attempts to start drilling. During each passes we are taking out chips and drilling in a clean hole again. In about 7 minutes I managed to drill precise hole in anchor stud metal part. Depth about 30 to 35 mm. You need minimum 25 mm deep hole with 10 mm constant diameter. Then little debluring to ensure that bolts fit tight to the surface. Let's evaluate result. For so primitive process, result is better than expected. Hole is almost in the center. This is a project's hardest part. Of course, not for a person with a metalwork skills, but for me and maybe other DIY beginners in metalwork, this is unbelievable success. And next I'm going to make anvils. First I'm cutting half of a 10 mm screw head to get flat anvil surface. At this moment I'm already skilled handsaw specialist working with confidence. Or maybe just approaching perfection. Now everything is fine and in a minute work is done. I need to repeat it 3 times. My wooden template is doing great job. I'm getting almost perfect flatness with tolerance of 0.1 or 0.1 mm. It is far better than I need. Let's take a look how it fits in anvil holder. In this project I made 3 anvil holders with different lengths, just in case I do have some complicated shape enclosure and need out-of-the-box solution. For press nuts I need 1.4 mm deep flat hole with 6.5 to 8 mm diameter. Optimized process would be using milling machine or lathe equipment. I don't have them. I will try to do it with a drill press. Drill press is developed to work with self-centering drills and not have a side load rigidity. Let's see and test is it possible at all. I'm going to make hole deeper than 1.4 mm and fine-tune necessary depths with the sanding process. Here you can see what's happening when applying extra force to mill. Mill holder is dancing. I find solution raising drill press RPMs and reducing load to material. Other 2 anvils are simple. I just need to drill 4.2 and 3.2 mm hole 15 mm deep in material. I'm using central drill to make a drill mark and with several passes drilling to necessary depths. Drill quality is great and it takes just a minute to finish a task. Screw material differs from anchor stud material and making long spiral type chips I should stop and clean them time to time. Final touch by polishing anvils with sandpaper. It should be really polishing, not sanding, because linear speed differs from rotating part center to edges, and you can lose a flatness. And the final operation, drilling hole in anvil holder to secure anvils. This operation is not possible without central drill. To make hole precise, I was using one setting, drilling hole in anvil holder and in anvils by placing them in anvil holder. Project completed. Let's take a look what we made. We have punch, we have anvil holder, anvil for press nuts, anvil for studs, and anvil for standoffs. For those who are lazy ones, I made one sample from 10mm hex screw without cutting it. It's usable. There is full set of today's accomplishments. 3 sets of anvil holders, 2 punches, and set of anvils. Now it's time for the field tests. Let's assemble Arbor press. Punch fits precise. An anvil holder as well. A little adjustments and drill press is ready for tests. I find out that it is better to use shorter punch. Then Arbor press handle will be at optimum place to apply force. And now demo. Pay attention how fast is clinking process, how easy to exchange anvils. Simple adapter, high flexibility, huge impact, great savings.